Okay, let's combine what we've learned so far into a series of questions, and we're going to go over those types of questions here in this lesson. So, this lesson is called Combining Transformations of Sinusoidal Functions. We're going to be combining the A, the K, the D, and the C value for our sine curve as well as our cos curve. Before beginning, let's just refresh our memory on what each variable represents. Okay, so A in this function here represents, first off, the amplitude, also the vertical stretch slash compression, and it's a reflection across the x-axis, okay, if A is less than 0. Okay, that's a reflection across the x-axis. K represents a horizontal stretch or compression by a factor of 1 over K. So if K is greater than 1, okay, so let's say K is 2, what's really happening is a horizontal compression of 1/2. Okay, there's a reflection across the y-axis. Okay, reflection across the y-axis if K is less than 0. And don't forget that you can find the period if you know K by simply doing 360 divided by K. D represents the phase shift, horizontal translation, left and right. And remember to use the opposite sign when you are figuring out your new x values. C represents the vertical translation up or down, and also happens to represent the equation of axis of our function. All right, so let's get into some types of questions that you might see. So for example here, it says state the amplitude, period, phase shift, and vertical translation for the following. All right, so what we're going to do is list out all of these items. Okay, so before we do that, let's write down what we know here. We know that A is 1/2. Okay, the absolute value of A, but it's also negative, so there's going to be a reflection there, okay, across the x-axis. K is 2, okay. D, what's D? If it's plus 180, what is actually happening to our x values? We are actually moving to the left 180, so negative 180, and C is negative 6. So let's state the amplitude, 1/2. And by the way, I probably should state a, let's state it, sorry about that. Let's state it as negative 1/2. And now when we state the amplitude, we know that we only use the positive value, the absolute value, which is 1/2. Our K, or our period, let's figure out our period next. 360 divided by K, which is 2, which is 180 degrees. So let's box all our answers that we needed to find. The phase shift is left 180 degrees. Okay, and the vertical translation, okay, is down 6 units. Don't forget now also that we need to say something, and the question didn't ask for it, but there is a reflection across the x-axis. Meaning a reflection up and down, okay, across the x-axis, because the A value is negative. Okay, next question. Again, let's find out, let's just write down what our A is. And D is positive 90, take the opposite sign, and C is 1. So our amplitude, very easy, is 6. Our period is 360 divided by K divided by 1/4. By the way, you could do it to, you can do 360 divided by 0.25. But don't be afraid to work with 360 divided by a quarter. Remember, when you're dividing fractions, you simply invert the second fraction and multiply. Okay, so 360 times 4 is 1440. Okay? Degrees. Phase shift. Right 90 degrees. And vertical translation is up 1 unit, which also happens to be our equation of axis. Okay. So straightforward enough. Now, they could have asked us to find more than that, like the equation of axis and also the horizontal stretch or compression, because remember that if K is 1/4, that there's really a horizontal stretch by a factor of 4. And here, it'd be a horizontal compression by a factor of 1/2. Okay, another type of question you might answer is the information might be given to you in words and you have to write out the equation. Okay, so state the function for each of the following transformations. If it's the cosine function is reflected in the x-axis, shifted right. Okay, well, first thing, let's write out what the cosine function is. Here's your cosine function. Now, let's gather whatever information is given to us. It's reflected in the x-axis. So A, and they're not saying by what, or that there is a vertical stretch or compression, which means that it's just 1. So it's -1. My A is -1. If they're not going to tell me that there's a vertical stretch or compression, assume that A is just 1. It cannot be 0, otherwise there'd be no equation besides the C value. So it can't be 0. So just assume that it's 1. And because it's reflected in the x-axis, it's -1. We are shifted right 45. Okay, that's what's really happening. We're shifting right. So when it's in my equation, it's going to say -45. And we're going up 3, +3. Is there a K value? Did they make any mention of a horizontal stretch or compression? Or did they say that the period changed at all? No. So then assume that K is 1, not 0. If it was 0, there'd be nothing here. Okay? Because you'd have 0 times a number and taking the cos of 0. Okay. So let's now sub everything in. So y equals, now I'm not going to put -1 for A. I'll just put negative cos. And I don't need to put the 1 for K. I'll just leave it and assume that if there's no number there, then it's just 1. And I'll put x minus 45, right? Because it's a positive 45. So in my equation, it shows as minus, and then +3. Okay, again, you do not have to write the 1 in front there with your square brackets. You don't have to do that. Okay? All right, next. Now we have the sine function. So y equals a times the sine k times x minus d plus c. This time we have an amplitude of 3. Didn't say anything about any reflection, so we'll assume that there's none. It says that the period is 720. So I need to figure out k if the period is 720, and I'm going to do that off to the side. Here's my formula for period that has k in it. I need to figure out k, and I know the period. I can do this. I can work backwards. Okay? How do I solve something like this? Cross multiply. So you get 720 times k is 360. Divide both sides by 720, and you get k is equal to 1/2. So here, k is equal to 1/2. Okay, and what about D? Was there any mention about left or right? If there's no mention about moving left or right, because it's added or subtracted, assume that there's a 0 there. It's not like if there's no mention of vertical or horizontal stretch or compression, because that's multiplied. This is just added, and so added or subtracted. So you can have a 0 for D and C, okay? Just not for A and K. I guess theoretically you could have it for K, but you're not going to really see any situations like that. Okay, and your C is shifted down 1 unit, so it's -1. And so when we sub everything in, did I really need to put the -0 there? No, right? In fact, I'm going to rewrite it as this. Okay, because it's just 1/2 times x, and that's it. With a -1 on the outside, because that's your C value, not your D value. Your D value would go inside the brackets, okay? Your C value stays outside the brackets. Okay, now let's do a question where we're graphing. Okay, so we're putting it all together and we're going to graph this function. Now, before we get to this function, I want to show you something. Suppose this equation was written like this. So 3 times sine, and then rather than have the 2, my k value outside the brackets, it's possible that you'll see some questions like this. Your k value cannot be inside the brackets like that when there's a minus or plus a d. What you need to do is common factor out your k value so that it's outside the bracket like this, being multiplied by x minus d. All right? Because the way your equation is supposed to look is like this. K and then a bracket, x minus d, close my square bracket, plus c. Right? And so this number here needs to be divided out of this bracket. So divide out your 2 and you end up with x minus 45, which is what we have here. Okay? So we common factored out the 2, brought it outside the bracket, and we're left with x minus 45. So be mindful of that because there's questions in your homework that try to trick you like that, where your k value is not outside your brackets, all right, when there's a minus or plus a d. Okay. So let's graph this. Now, I don't have a straight edge here, but that's okay. So what I'm going to do is just draw as best as I can a straight line here going down. I'm going to go right there. Okay. And go across. And I'm going to wait to go across yet because we'll figure out what our scale is first before I see where our graph might lie. Okay, so before I do that, let's actually do our table of values. Okay, so now here we go. Let's write down what we need to know here. We need to know that A is 3. We need to know that K is 2. We need to know that D is 45, positive 45. C is -2. Because now I'm going to do my table of values for my sine function. Okay. Here's where I'll put my new x values. Here's where I'll put my new y values. Okay. My original x values, and by the way, this is sine. Yeah, it's the sine function. So 0, 90, 180, 270, 360. Okay, and for the sine function, it starts at 0, goes up to 1, back to 0, down to -1, and then back up to 0 again for one full cycle. Now, my new x values, okay, I know that my k and my d are what affect my x values. I know that my k value, the reciprocal, gets multiplied by my x's. The reciprocal gets multiplied by my x's. So I have 1/2 times all my x values, right? Because k is 2. Now, in the equation, it's -45. So what's really happening to my x values is I'm moving them right 45 or adding 45. So I'm going to sub in my x values into this expression here for each of these x's here. So here we go. 1/2 times 0. Okay, so let's actually 1/2 times 0 plus 45 equals 45. Okay, 1/2 times 90 plus 45 equals 90. 1/2 times 180 plus 45 is 135. 1/2 times 270 plus 45 is 180. And 1/2 times 360 plus 45, okay, is 225. So our graph shifted to the right 45 degrees, okay, and you can see that right here. But then also it got multiplied by a factor of 1/2 because my k was 2. So my x's got multiplied by 1/2, and then I added 45 to them. So now I have my new x's. Now let's figure out my new y's. They're a little bit easier. There's no reciprocal. There's no tricks to this. There's no opposite signs. It's simply take your a, multiply it by all your y's, and then subtract 2 or move each point down 2 units. Okay? We're now going to sub in all of our y values into this expression. Okay? So 3 times 0 minus 2 is -2. 3 times 1 minus 2 is 1. 3 times 0 minus 2, back to -2. 3 times -1 minus 2, be careful. This is now -5. It's -3 minus 2. And lastly, again, back to -2. So here are my new x's. And to recap, what I did here was I know that my k value, the reciprocal, gets multiplied by my original x's. So I did that right there. I also know that my d value gets added or subtracted to my original x's that are being multiplied here. And so I added 45 to them to shift them to the right 45 degrees. My y's are multiplied by my a right there. Then subtract 2 from each y value because we're moving all the points down 2 units. Okay? And now we're going to plot this, and we're going to plot this here. Let's figure out a scale. On the x-axis, or let's figure out the y-axis first. We've got to obviously go -1 and 1, and then we've got to go as low as -5. So I need to put my axes perhaps a little bit higher up here. So maybe I'll put it right about, we got to go down to -5. I'll put it right about here. Okay. Now you're going to use a ruler, of course. I just don't have the ruler function here or being able to draw straight lines here in Microsoft OneNote. Okay, so again, like I said, I'm going to go down to -5. I'll skip a line because I think I have enough room. I do, just enough to get down to -5. And skip a line here, I can go up to 2. On my x-axis, I need to have 40. I'm going by 45s here, right? Because I need a 45, I need a 90, I need a 135, I need a 180, a 225, and then I also need a 360. So going by 45s makes perfect sense. And I think we'll be able to skip, let's see here. Skipping 3 lines should be pretty good here. So 1, 2, 3, that's 45. 1, 2, 3, 90, and so on. Just go by 45s. Okay, you're going to have to play around with this before you figure out a proper scale for sure. Okay, and that's okay. Like if you didn't do the right scale, just erase it. Try a new scale. Make sure this is in pencil, right? It happens. Okay, so we're going by 15s essentially, but what you see is going by 45s. And so now let's plot our y equals sine x graph. So let's start, this should be a period of 360. Oops. Okay, and there it is. I've memorized the points now, okay, and you'll hopefully get to the same point. There is our y equals sine x. Now let's see our y equals, well, this function here, okay? It's our new sets of points here. So I have, and I'll do it in a different color, I have 45, -2. Right there. I have 90 and then 1. So it shares that point there. 135, -2. Back down. 180, -5. This is where it goes right down to -5. 225 back to -2. By the way, you can see that the equation of axis is at -2. Okay, all you have to do is look at your C value on your equation and you can see that. So let's draw our curve. Now remember that this goes on forever in both directions. We're only drawing one cycle of this, but it goes on forever in both directions. Okay, we're only drawing one cycle, however. And there you have it. You have our new sketch plotted. Okay, and you can verify that the graphs look like this. You can do them, you can type them up in Desmos and verify that. Okay, but this is what you'll need to do in order to answer a question like this. You set up a table of values of your parent function. In this case, it was y equals sine x. Then figure out your new x values by looking at your k and your d values. Okay, multiplying x by 1 over k, or the reciprocal of k, and then adding your d. Figure out your new y values by multiplying them by 3, or sorry, by multiplying them by a, and then adding or subtracting c. Okay, and then you plot your new points. Now, I'm not going to answer the next question, but I will set it up for you. I'll set up your table just so you can see how to create another table. So, from the equation here, let's write out what we need to know. A is 2. K is a half. D, if it's plus 90, we are really subtracting 90. We're going left 90. And C is 4. So I know my equation of axis will be at 4. Plus 4. Okay, not that you have to write that, but now, it's the cos function. So when we do our parent function, make sure that you're doing it for the cos function. Okay? Parent function is straightforward enough. The cos function starts at the max, goes down, and then back up to the max again. Now, your equation for your new x values. If k is a half, what are you really doing to your x values? What's happening to your period? It's doubling. So we're actually going to make our x values twice as large. And then we're going to take what's really happening, and this is what's really happening to our values, our x values. They're actually going to move to the left 90 degrees, so subtract 90. And lastly, for your y's, take your a, that gets multiplied by your y's, so 2 times y, and then add your c value or subtract your c value. In this case, we are adding. So you're going to take all your x's and sub them into here, right? So 2 times 0 minus 90. Look at, we're going to be in the negative side here, negative 90 degrees. Okay, then 90 degrees. Here, we're going to be at 270. And next, okay, so we will be at 450 here. Okay, and then 2 times 360, that's 720, minus 90 will be at 630 there. Okay, so you can see there's a 180 degree swing in between each of these, 180, 180, and so on and so on. Okay. Now let's find our new y values. So this time we're going to do 2 times 1 plus 4 is 6. That's 4. 2 times negative 1 plus 4. Okay. That's negative 2 plus 4, which is 2. 2 back to 2 times 0 plus 4. We're back at 4. And then 2 times 1 plus 4. Oops. We're back at 6. Okay. Remember, your equation of axis will be at 4. And so you're going to now plot these new x and y values along with your original parent function. You always plot the original parent function as well, so you can visualize what transformations have occurred. So I'm not going to actually graph it for you, but you're going to need to obviously go to negative 90 on the x-axis up to 630. So you've got to figure out a scale that will cover all of that there. Okay, essentially going up to 720 degrees on the x. And on the y, you can see that most of your graph is going to be in the positives, right? Like positive 6, 4, 2, 4, 6. You've got to go as low as negative 1 to accommodate your parent function, and then as high as positive 6 to accommodate your new function. Okay, so you can, you're going to probably draw your line somewhere at the bottom here and only go down somewhere at the bottom there, and because you only need to go down to negative 1, right? But you've got to go as high as positive 6. Okay, that does it for lesson 2.4. Okay, certainly you need to practice, in particular, setting up these tables of values, okay?